to episode 2 of Talking Data, the only show on the internet focused solely on data use in the public schools. Today's episode, episode 2, Colorado Growth Model, is aimed at keeping the conversation between you and data alive and well. We want to do two things in today's episode. First, we will explain the Colorado Growth Model, and second, we will explain how to look at a new report just created and how you might make the most of these data. Colorado's growth model will enable schools, districts, and the state to understand how students progress. Its intent is to provide a common, statewide understanding of how much growth is needed for each student to reach expected levels of proficiency. Colorado's growth model also tells us the growth percentile a student needs to reach proficiency within 3 years. This answers the question of how much growth is enough for a student and allows CDE to summarize the percentage of students that are making enough growth to reach proficiency within 3 years or by the end of the 10th grade. Let me try to explain this in simple terms. In Colorado, we have around 700,000 students take CSAP each year. These students are spread all over the state of Colorado, each taking the CSAP reading, writing, and math. Some also take science. To obtain a student's growth percentile, a student is only compared to his or her academic peers, or those students that start at the same point they did. So, for this example, I'm going to introduce you to Wesley. Wesley is a 5th grade student in Colorado, and in 5th grade, Wesley scored 635 on reading. Wesley, from Denver, Colorado, will only be compared to students that look just like Wesley, or, in other words, students that scored very similar to Wesley, like this Wesley down in Lamar, this Wesley in Durango, and this Wesley up in Sterling, all scored about 635 on the CSAP, so they will be compared to each other. The rest of these students, for the growth model, well, they no longer matter. So how do we get Wesley's growth percentile? We take all Wesley's academic peers and look at their growth. The peers are then ranked from highest to lowest. With the highest being the 99th percentile, or scored better than 99% of their peers, and the lowest being the 1st percentile. Wesley, in this case, let's say, gained 20 points and grew from 635 to 655. This, let's pretend, is the 50th percentile. Wesley made normal growth. So did all the students that scored between the 35th and 65th percentile. Any student above the 65th percentile is considered to have high growth. And any student below the 35th percentile is considered to have low growth. What is really neat is that the model allows the state to estimate how much growth a student needs over 1, 2, or 3 years to achieve proficiency. That is, if they're below proficiency. This creates a growth trajectory for each student that is needed to achieve proficiency. Now let's move from Wesley's story on to talking about the report. Bye, y'all! This report is organized in the following way: by school, grade, subject, and last year's proficiency level for the student. In addition to that, all students are sorted ascending by scale score. This allows you to look at students who were U, PP, P, or A last year together as a category and see whether there are patterns of growth within and between these groups of students. If I were looking at these data, I might look for groups that made more growth than others as an indicator of instructional practice. For example, if the low students were making more than normal growth, but the high students in general were making less than normal growth, we might ask what we're doing for the high students compared to what we're doing for the low students. Now, as you look from left to right, you see this year's proficiency level here, and this year's scale score, current year scale score, here. Next is the growth percentile. This is what I described in part 1 of this episode of Talking Data. Greater than 65 is considered good growth. Less than 35, not good. The final 3 columns here show the percentile needed for 1, 2, and 3 years into the future to achieve a proficient level. On the top line, you can see that a student grew in the 78th percentile here, started partially proficient, stayed partially proficient, but grew in the 78th percentile, and to achieve proficiency by the end of their 6th grade, because this was the end of their 5th grade, they need to grow in the 91st percentile, or by the end of 7th grade, they need to consistently do the 75th percentile, or by the end of 8th grade, they need to consistently grow in the 71st percentile. Now it's your turn. Go take a look at the report and let the data talk back.